All right, class, in this lesson, we are going to talk about the linear search algorithm when handling arrays or array lists. This should be a topic that should be intuitively obvious once we talk about the steps and what our goals are. So this is a linear search. Linear meaning we are going in one line. We are not breaking up our search, we are going straight through. And as the second part implies, we are searching for something, which means that we are going to have to check a condition. So we're going to go through in a line through an array or an array list, and we are going to search for something. We're going to have a conditional statement, our friend, the if statement. So the linear search takes really three basic steps. The first step is that we are going to search in a linear fashion. So we're going to start at the beginning of our object, at the beginning, i.e. index 0. Right? So we're going to start at the beginning. Then we are going to go through and we're going to check, is this the value we're looking for? Let me write that correctly. Is this the value? So is this the value we're looking for? If yes, then we need to stop searching and do our thing. So if yes, let's make that green. If yes, then we stop searching. And if it's no, move to the next item. And step 3, or I guess it's part of this no here, is then we repeat 2. Until we reach the end of the list. Or we find it, right? So we repeat 2 until we reach the end of the list, or if we find what we're looking for. This is the basic algorithm of a linear search. Now, this algorithm has some advantages. So it has an advantage. And the main advantage is that this always works. Right? If we're looking for something, we're always going to guarantee that we check every item in the array because we're going all the way through it from the beginning to the end. But there's a bit of a drawback to this. Because we always go from the beginning to the end, the disadvantage is that this is slow. So why would we want to use linear search? The reason we want to use linear search, and the use case we're going to use it for, is whenever we have unsorted data. This is what it's good for. Unsorted data. When the data is not in an organized fashion, when it's just a pile on the ground. Imagine, if you will, trying to look through a deck of shuffled cards. If you can only look at one card at a time, like a computer can only look at one item in the array at a time, looking through a shuffled deck of cards, it's going to be very hard to find the particular card you're looking for. You're going to have to go through one card at a time to find that item. That's where this has the advantage. We can always guarantee that we're going to go all the way through that deck of cards, but it's going to take us a long time to get through it. Don't worry, we're going to solve this slow problem a little bit later once we learn how to sort our data, which we're going to do soon. Okay, so a linear search. This is what it is in plain language. Let's look at what it looks like in Java. So there are, of course, different ways to write this. I'm going to write this as a modified for each loop or enhanced for each loop. And the reason I like to write it as a for each loop is because in a for each loop, we guarantee with simple syntax that we're going to go through every single item within our object. So let's assume that we have an array of, or even an array list of strings that we call words. Okay, so we're going to have some kind of data structure with words, called words, that has strings. Okay, and we want to search for a string within this object that equals hello. We're also going to assume that we have written this within a method. And this method will return a string. Actually, you know what? I'm going to change my mind. It's going to return true or false. So whether or not it finds hello within this collection. We're not going to worry about passing that collection or anything like that. We're just going to do our linear search. Okay, so how do we do it? This is what the algorithm would look like. So imagine we already have our header. We already have all this data set up. This is just the search. So here we go. For, and we're going to use the enhanced for loop syntax here. String, word, from words, I want to check if this equals my conditional string here, hello. So I would probably want to hard code hello, or not hard code, but I'd probably want to code hello into a variable or into a constant, even better. But in this case, we'll go ahead and code the string literal. And I'm going to write my if statement here. This is my step 2. So step 1, for loop, right? This is our part 2. This is asking the question if word dot equals hello. And in this case, I do care about case. So I want it to equal hello with a capital H. So I'm going to use standard equals. Then I'm going to return something, and this is my yes condition. So yes condition of my second part of this algorithm. If it equals hello, then I'm going to go ahead and return and actually this is going to stay blue, return true. Okay, so I return true. Now, if we look back at the list here of what our algorithm is in plain language, we start at the beginning, good, we set that up with our for loop. Is the value, right? So have we found the value we're looking for? Is this the value? Yes, we're doing the yes condition. We already said yes, return. And remember, return has that special property that it kicks us out of the code wherever we are. So it's automatically going to stop the search when we have that return inside the if statement. So we've answered this. We've completed all this. Now we just need to complete the last parts. No, move to the next item. Well, all we have to do in move to the next item then is simply complete the loop. So completing the loop here, but we also need to say return false. So this is going to go all the way through our array list or array, whatever data type this is. It'll work for both. Return true, and of course our default, if it gets all the way to the end of the list, return true never happened. We simply put a return false and then this would close the method. Return false just before the end of the method, and that would return our false if we did not find hello. And that's all that there is to the linear search. Of course, we could write a standard for loop, and we could have some variations within this, but this is the basic structure of a linear search when we are working with unsorted data. Next lesson, we're going to learn our first technique on how to actually sort data. All right, I'll see you guys in the next one.